This is a big gun. We know the derivative of a constant is 0. If the derivative of y equals x to the n, so essentially what we're going to have is that f of x equals x to the n power. Any power. X to 1, x to the million, x to the negative million, x to the 1/2. N can be any number, any numerical value. Using the definition of the derivative with respect to x of x to the n is the limit as x goes to 0 of f of x plus h minus f of x all divided by h. F of x plus h minus f of x all divided by h. Now, I have to expand this sucker. And to do that, I use something called the binomial theorem. And some of you may have seen it in college algebra, some of you may not have, and it kind of doesn't matter. What it says is this: I start out with x to the n, then there's going to be some number plus x goes down in power, h goes up, then some number, x goes down, h goes up, all the way down till I end up with h to the n power. If I were going to look at x plus y cubed, if I were to expand that out, that would be x cubed plus 3x squared y plus, I'm picking an easy one, 3xy squared plus y cubed. X goes down a power for each term, y goes up a power for each term. That's how this guy works. Whether it's to the, whoops, sorry about that. Whether it's to the third, fourth, fifth, and the numbers in front of the each term is called the binomial coefficient. And that's how this guy's going to operate. Some of you might be a little bit more familiar with Pascal's triangle. Pascal's triangle gives you the binomial coefficients. That's how I got this. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. There's your cube right there. And that's the binomial coefficient in front of that cube. To the fourth power would be 1, 4, 6, 4, 1. Those are your binomial coefficients. Pascal's triangle. So those would be the coefficients of x plus y to the fourth, if I were to write that out. But the more important thing for you is the pattern. So that when I expand it out, which is what happened, you notice that the x to the n's add to 0. And every term that's left has a greatest common factor of h. The h's reduce out. Then you'll find all of the inside terms will add to 0. And what you get left is this term right here. As the limit, as h goes to 0, I'd have zeros for everything because everybody else except this first term has an h in it. So that you're left with nx to the n minus 1. So that says, what is the derivative of x to the n? The derivative of x to the n is nx to the n minus 1. You bring the n down in front and you subtract 1 from the exponent. So that f prime of x would be 100, bring the exponent down, times x to the 100 minus 1, which is 100 x to the 99. Power rule. Big guy, big gun, important. Yes?
Where does the C come from the...
It's just some binomial coefficient. Remember, I didn't put the binomial coefficients in. I could have, which would have really blown your minds. But all it is it's some coefficient, binomial coefficient. It's some coefficient. Because if I expanded, like when I expanded this guy, was there not a number in front of each one of those terms?
There is.
Yeah, it's just some number. Don't have to worry what it is. It's a constant because as h goes to 0, what happens to that term regardless of the number that's in front of it? It's going to go to 0. So where did the c come from? It's just some number. It's a constant. So it's going to go to 0 as h goes to 0. So whatever that number in front is not going to make a hill of beans. So that's power rule. And by the way, it does not matter what that exponent is. Exponent in front, variable to the exponent minus 1.
So does it matter? Do we have to go through all that, or can
No, that's why it's true.
we just go straight to that? Rule?
Yes. Now that we've done it already, there it is.
Okay.
Now we have the rule. Now we don't have to worry about where it came from. We just have the rule.